guys, welcome to Ask IITians. My name is Gaurav Yadav. I hope you all are doing well. So guys, today we start a session for your topic symmetry. Okay, so let me just share my screen. We have already discussed symmetry. We have discussed line of symmetry. Okay, we'll move forward to a new topic from symmetry. Okay, so yeah, we have already discussed symmetry in our previous session. Okay. So today we'll cover topics your line of symmetry. I think we have already covered. We'll see what next into this. Then your reflection, your rotation symmetry, your order of rotation symmetry. Let me just tell you what symmetry means. Symmetry generally means a figure from which if you just fold it, you will find that the figure repeats itself. Okay, for example, in an isosceles triangle, in this isosceles triangle, you will find that two sides are equal in a triangle, right? You will find that this is your angle of sorry your line of symmetry. Okay, line of symmetry. It means that this line will divide this triangle into two parts such that their part will act as if you just fold one part into another, it will just overlap or it will just coincide, right? So this line of symmetry acts as a mirror. Okay. For example, if I take a real life example, right? If you see your face, I'm just drawing. Suppose this is your face, okay? Your nose and your lips, okay? Your ears and your ear also. Don't make it bald, okay? You will find that your face is also symmetrical from left to right and from right to left. Why? If you just draw a vertical line, you will find that one face will overlap on the other face, other part of face. If you just fold it up, right? So it is basically your vertical line of symmetry. I think you all have got the point that your face is a symmetrical face, because if you just put a mirror right above your what nose, you will find that your left face and your right face will just overlap when they are folded up. Okay, if you like, I have also given an example. For example, your jeans or trousers you are wearing. This is also a symmetrical figure. If you just draw a line, right, like this, the diagram is not drawn properly. So these will act as a line of, as a symmetrical figure, because basically the symmetrical part is it divides into such that the other two parts or the parts are just symmetrical. Okay, so this is your vertical line of symmetry. Okay, vertical line of. This is what is known as reflection reflection symmetry. Reflection symmetry means it will just act as a reflected part. Okay, if you just put a mirror in the x-axis triangle in the between, or it will act as a like an attitude. Okay, so this will act as a mirror. This will act as a mirror. In case of your face, if you just draw a line, you just draw a line. If you see that your face will repeat itself, then this line acts as a mirror. Okay, so basically, in case of mirror, these are known as reflection symmetry. We'll discuss rotational symmetry. Rotational symmetry means that at some particular angle, if you have rotated the figure, then it will repeat itself. For example, star. The figure is not okay. For example, your star. Okay. The star has a line of symmetry also. If we just rotate it, if we just rotate it by 60 degrees, you will find that this figure repeats itself, right? So this is known as rotational symmetry. I think you all have got the point what it means by rotational symmetry and what it means by your reflection symmetry. Okay. So these are some real life examples and some figure. So basically, uh, just look at the diagram. Just look at the what reflection means and what rotation means and what translation means. We'll tell you what translation. Just look at. Just look at the diagram. They are basically three kinds of symmetry. First is your reflection one. Reflection means your angle of, so your line of symmetry. Line of symmetry. Uh, or in that case, use this line. Your line of symmetry means your line of symmetry will act as a mirror. Okay, this acts as a mirror. Second is your rotational. Rotational means that if you just rotate it at some angle, rotate at some angle, the figure repeats itself. The figure repeat itself. This is what the rotational is. So, like the bird shown in the figure as a reflection, it is basically a mirror one, right? And if you just rotate it, then it is a rotational symmetry, right? And the third one is translation. Translation Translation is neither if you neither reflection nor rotation. This is just a slide one, right? If you just slide or move in particular direction, in particular direction. So this is what these three types of symmetry. Okay, but in our subject, in our content, we will study only two: reflection and rotation. We have already covered. We have already covered what? We have already covered your reflection one, that is angular symmetry. Now we'll cover your rotation. Okay. So let us just have a brief idea what line of symmetry means. Reflection symmetry, or basically line symmetry, or mirror symmetry, mirror image symmetry. These all are basically all are the same one. Okay. You can see reflection symmetry, line symmetry, mirror image symmetry. Is symmetry with respect to reflection. Okay, with respect to reflection. This figure, which does not change upon undergoing a reflection, has reflection symmetry. In 2D, there is a line axis of symmetry. In 3D, a plane of symmetry. We have already covered here equilateral triangle. We'll discuss about equilateral triangle. That in case of equilateral triangle, three lines of symmetry will be there. Basically, it is a polygon. So a regular polygon will have how many numbers of symmetry, how many lines of symmetry depends on the n, the sides, right? So it will have one symmetry like this from one vertex to other side. You can just overlap the one side to other. If you take this part also, it will have second line of symmetry, and this is what third line of symmetry. So the same case with square, same case with regular pentagon, it will have five lines. A square will have four lines, and your triangle will have three lines. Your regular hexagon will have what? Six lines. Your regular octagon will have eight number of lines of symmetry. Regular polygons have lines of symmetry equal to the number of sides or angles that they possess. Okay. So basically, regular polygon will have n lines of symmetry. Depends on n. What is n? N is the number of sides or the number of angles. Okay. So this is what we have already discussed in our previous session. Now we'll study rotational symmetry. Symmetry. So rotational symmetry, also known as radial symmetry in biology, is a property a shape has when it looks the same after some rotation by a partial turn. Right? If you just rotate some shape, so it is known as the rotational symmetry. An object's degree of rotational symmetry is the number of degrees of orientation in which it looks exactly the same for each rotation. Basically, a shape has rotational symmetry when it still looks the same after some rotation of less than one full turn. For example, a star. For example, a star. If you take a star, if you just rotate it by 60 degrees, you will find it will repeat itself. Okay. So basically, it will have how much? Six. order. We'll discuss what order is and what rotation means. Okay. Uh, so yeah, discuss center of rotation. For a figure or object that has rotational geometry, the fixed point around which the rotation occurs is called center of rotation. Example, the center of rotation of a windmill. In the center of the windmill from which this place ordinarily rotates. I think you already have, you know what windmill is. Just take the example of a wind. This is your center of rotation. If you just rotate it, right? So these all blades will repeat itself after some angle. Okay, angle of rotational symmetry. For a figure or object that has rotational symmetry, the angle of turning during rotation is called angle of rotation. Example, when a square, okay, so just take an example of square. Right? If you just look at this point, A point, right? And if you just rotate it at clockwise direction, what will you find? That the figure has repeated itself. And the point A has gone to this direction. If, okay, this is what you A has gone. But the shape is same. The shape is same. So this is Y rotating 90 degrees. Okay. One, then again at the 180. If you just make it a 180, you will find that you A, if you just again rotate it by 90 degrees, you will find that you A will go to this point. If you again rotate it at you 90 degrees, you will find that your A has gone to this point. If you again rotate it by 90 degrees, you will find that your A has come to the same original one. So how many times you have rotated the figure so that it repeats itself? So basically you four times, right? So four is your order. Four is your order of rotational symmetry. Will tell you why. Will tell you why. Okay. So basically, the order of rotational symmetry, the number of positions in which a figure can be rotated and still appears exactly as it did before the rotation is called order of symmetry. For example, a star can be rotated 5 times along its tips and look at the same every time. Hence, its order of symmetry is 5. Okay. So basically, a star. I think we have done some. It will not rotate it by 60 degrees. It will rotate it by 72 degrees. So basically, it will have 5 order, right? It will have order 5. 72 degrees. 5 order. Okay. So star, if your star is rotated by, the diagram is not proper, guys. Just take it lightly. Okay. So if you rotate it by 72 degrees, you will find that order is basically what? Order is basically 360 divided by the angle at which your one angle at which your the figure will repeat itself. It is basically 72 degrees. So you will find 5 times. So basically your order of symmetry is 5. Okay. For example, in square, the angle at which the figure repeats itself is 360 degree divided by 90 degree, which is 4. Right? We have already calculated 4 order. Okay, 4 order of symmetry. 4 order of your rotational symmetry. If a figure is rotated around a central point and it still appears exactly as it did before the rotation, it is said to have rotational symmetry. I think the point is clear. A number of shapes like square, circle, regular, hexagon have rotational symmetry. So, guys, what will be the rotational geometry or order of equator triangle? Equilateral triangle. Each angle is 60 degrees, right? And line symmetry 3. So it is basically 360 by 6, that is 6 order. Why? It will just repeat after 60 degree of rotation. Okay. Square, we have already covered 4. This is equal to minus 6. Rectangles, rectangles will also have 4. Guys, circle. We'll discuss circle. Circle has infinite numbers of what? Infinite numbers of lines of symmetry along a diameter. So circle will have infinite order of symmetry. At each angle, you will find that it repeats itself. So, right, it will have infinite. And in case of regular polygon, like your pentagon, your hexagon, right, this depends on basically on your n. Your so the n times of order will have uh, order of symmetry. In regular polygon will have n order of symmetry. Why? Because your n is basically your number of sides or angles. For example, hexagon. Hexagon have 6 lines of symmetry. 360 by 60, it means 6 order. Swastik symbol. Guys, swastik symbol has an order of symmetry 4. Let me tell you why. I think you all know what swastik symbol is. This is how swastik symbol looks like at our home we have already changed this symbol, right? So if you just rotate it by 90 degrees, you will find that its figure repeat itself. So if you 360 by 90 will be what? 4. So it will have 4 order of symmetry. Order of symmetry means the number of angles about which the number of times the figure repeats itself. Okay, from 0 to 360, right? We do not consider your one order of symmetry. Why? Because every figure of 360 angle will repeat itself. So, right, we do not consider one as order of symmetry. So, a question is there for you guys. Question is there for you. Question is, name 2 figures that have both line symmetry and rotational symmetry. So yeah, equator triangle is a figure. Have you done six here? And if you just look at your equator triangle, each angle is 60 degree, but if you just rotate it, this will repeat itself as 120. It will have 3, right? Why? Because like it is a regular polygon, right? I have already told that in regular polygon, the n number of sides and angles depends, right? So 365 120. If you just rotate it by 120, it will repeat itself. So basically, three order of symmetry will be there. Okay. So yeah, any two figures that have both line symmetry and rotational symmetry. So yeah, equal to triangle, square. So basically, a square has how much? Four lines of symmetry. And order is also four. 360 by 90. Order is also what? Four. And equal to triangle will have three lines of symmetry and three order. I think you all have got the point. Two figures that have both line symmetry and rotational symmetry. So question is, give an example of figure that has line symmetry but does not have rotational symmetry. Okay. So your isosceles triangle, isosceles triangle has line symmetry like this, but no any rotational geometry. Like there is not particular angle for which you will rotate and it will just repeat itself. So basically, one line of symmetry, but do not have rotational symmetry. But also a semicircle. You will find that your semicircle there is a line of symmetry, one line of symmetry, but no rotational symmetry. These two figures have one line of symmetry, but no rotational symmetry. Okay. Give an example of geometric figure which has neither a line symmetry nor a rotational symmetry. Guys, the example is your scale and triangle. Scale and triangle. Scale and triangle has neither a line of symmetry nor a rotational symmetry. Okay. I'm telling you that your one order is not considered because you know that every figure if you rotate by this speed, that every figure will just rotate. So question is give an example of a letter of the English alphabet which has no line of symmetry. No line of symmetry. The example is Z has no line of symmetry. Another example you can also take G, right? Also Q. These have no lines of symmetry. Rotational symmetry of order 2. So yeah, N has of order 2. Why? If you just rotate it by 180 degree, 180 degree, it will just repeat itself. So 360 by 180 will be what? So what is the line of symmetry? A semicircle, does it have rotational symmetry? Like we have already discussed. In a semicircle, the line of symmetry is what? 1. And does it have rotational symmetry? No. A semicircle, half of a circle. One line of symmetry. In the figure, there is one line of symmetry. The figure is symmetric along the perpendicular bisector diameter xy. A symmetrical does not have rotational symmetry. Like you cannot rotate it at some angle and the figure will repeat itself. Okay. Draw whenever possible a rough sketch of triangle with both line and rotational symmetry. A triangle is what having both line symmetry and rotational symmetry is an equilateral triangle. Your equilateral triangle has three lines of symmetry, and if you just rotate it by 120 angle, right, you will find that 360 by 120 will be what three order and three lines of symmetry. Three lines of symmetry. This is what equilateral triangle. Okay, so second part is this is what your first part. Second part is a triangle with only line symmetry and no rotational symmetry. We have already discussed. This is the case of what? Isosceles triangle. One line of symmetry. One line of symmetry. And zero rotational symmetry. Or you can say no rotational symmetry. Okay. Scalar triangle has neither rotational nor line of symmetry, right? A quadrilateral with rotational symmetry but not a line of symmetry. Third example, you can take your parallelogram. Your parallelogram no line of symmetry. We have already discussed in our session line of symmetry. No line of symmetry. But have rotational symmetry, guys. This have rotational symmetry. How? If you just look at the point A, and this will be just rotated by 180 degree. So it will have 260 by 180. That is two order, right? So you will find that after 180 degree, the diagram will look like this. This point A will reach to there. The fourth point, a quadrilateral with line of symmetry but no rotational geometry. So just think about a quadrilateral with line of symmetry but no rotational geometry. Basically, kite has one line of symmetry, but No rotation geometry. Geometry. I'm telling you that your 360 degree or one order is not considered because every figure just rotates itself. So, what is the base of question? Is what is the base of heptagonal prism? Hepta means your seven, right? So the question gives answer itself heptagonal prism. So yeah, definitely heptagon will be your answer. So yeah, just read out. You will get your octagon. Octagonal prism means eight side, eight figure. Okay. Pentagonal is your five. Your pentagon will have five order of rotational geometry and five lines of symmetry, right? So yeah, pentagon. I think the line of symmetry and the order of symmetry is clear to you guys, right? So we'll meet you in next session. We'll meet you next session, guys. So till then, please practice more and more questions as you can do from your reference book and from your NCERT one, right? So yeah, thank you guys.